In example 8, we want to find the general solution to the differential equation dy dx is equal to x times the cosine of x squared over 4y. And we also have a restriction here that y is greater than 0. The very first step in finding a general solution is to separate your variables. So we'll multiply each side by dx, and we're also going to multiply each side by 4y. If we multiply each side by 4y and dx, watch what happens. The dx cancels on the left, and then the 4y cancels on the right-hand side. So we wind up with 4y is equal to x times the cosine of x squared, and then we have dx. We've successfully separated our variables, so now it's time to integrate each side, and I completely forgot to write down the dy. That still has to stay on the left-hand side, so we'll sneak that right in there. So now we're going to integrate each side. If I find the integral of 4y, or the antiderivative of 4y, that's going to be 2y squared. If we find the derivative of 2y squared, we wind up with 4y. So it's a good double check to do in your head. On the right-hand side, we have a little bit of a trickier situation. So what we're going to do here, if you need to, is we're going to do a little u substitution. So I'm going to let u equal x squared, and then du dx will equal 2x. And I also know then that du over 2x will equal dx. So in the next part, what I'm going to write down is my integral symbol. I've got x times the cosine of u. Remember, we're letting x squared be equal to u. And then dx here can be replaced with this piece right here, which is du over 2x. Notice here that the x's will cancel, and I can write my integral symbol again. I've got, let's see here, I've got the cosine, or 1/2, times the cosine of u du. And then if I stick with the color scheme here, we've got 2y squared is equal to on this side. Now what I'm going to do is work with the right-hand side to try to find the antiderivative of 1/2 times the cosine of u. And that antiderivative, of course, is going to be 1/2 times the sine of u. And that'll be plus c as well. The one thing that we need to do is now change that u back into something in terms of x. So I'll keep my left-hand side as 2y squared. And then I'll write 1/2 times the sine of x squared. So we need to substitute back in there for that u, which we let equal to x squared. If you take a look at the part right here that we just wrote down before, of course, that's plus c. And then what we'll do here is we'll divide by 2 everywhere. And if I divide this by 2, it's the same as multiplying by 1/2. So I can multiply that by 1/2 and then divide the other term by 2. So the 2's cancel. I wind up with y squared is equal to 1 over 4 times the sine of x squared plus c over 2. The last part of this is just to take the square root from each side, or take the square root of each side. And I'm going to go back to the original problem, and it says here that y is greater than 0, if you can see that right there. And because y is greater than 0, we only want the positive square root, but I do want you to think about whether or not you need the plus or minus sign there. However, we can just write this as this y is equal to the square root of 1 over 4 times the sine of x squared plus c over 2. And if I look at my answer choices here, I don't actually see that exactly, although I see one that's pretty darn close. Part D doesn't look like that at all. Part C, the 1/8 right here without a square root, is an issue. And then we actually can't break out that 1/2 in front because we have to take the square root of the C part as well for part A, so that doesn't work. Everything underneath this radical sign is actually the same with the exception of the C right here. Well, the good news for us is if we take a look at what we've written down as our answer, which is this part right here, Any number divided by 2 is just another number. So that could be just a constant. So actually, part B is the correct answer that we want for this particular problem.